Well, we're going to move on to pages 16 and 17 in the second piece of Algebra 2, 1122. And part of this is determining whether a series is convergent or divergent. And those two terms may be totally new to you, and maybe you don't really even have much reference to go by to know what those terms mean. But let me take the root word converge and think about, have you ever been to a stadium and maybe there's a lot of people in the stadium and they're all trying to get out at the same time, and there are different entrances or exits where they can get out. So we would say that the crowd is converging to those exits. Okay, so converge means to all come together down to a narrow point. So using a picture, it would be kind of like these lines are converging to a smaller point. Starts off big, gets smaller. Divergent is the opposite then. Starts small, gets bigger. So it's kind of like all those same fans leaving a stadium, and when they come out of the exit, boom, they start to scatter and go in all different directions. Okay, or coming out of church after a church service. All those people come out the one door and then boom, they scatter and go across the parking lot. So that is divergent. When we're talking about a series, in a series, each one that comes next in the series is bigger and bigger and bigger and bigger. And so if you were to try to find the sum, that's what the S stands for, add up all of the terms in a series, as it's getting bigger and bigger and bigger and bigger, there's no end to it, because those numbers just get huger and huger. So you keep adding the next number, the next number, the next number, and you go out there 100th to the 100th term or the 1000th term. They're getting so huge. So we would literally say that it's approaching infinity, okay? So there's not much value in that. We don't pursue that one. But if an equation, a series, is convergent, then after a while, it's getting smaller and smaller and smaller decimal numbers, so that the next one is getting closer and closer and closer to zero, okay? And so we do reach a point where we could basically find out what the sum is. And it would be very close to that. It would round off within just a little bit to a very specific number. So this is the formula. We start with the first term, and then we divide by 1 minus the ratio between the terms. And this just is the condition that has to be met. So if the ratio is less than 1, then we say that it's convergent. If it's greater than 1, it's divergent, and really we just kind of ignore that. It's just approaches infinity, okay? I'm going to do one problem for you. They give you a couple examples in the piece. This one problem is from your homework. So if you watch this video, you're being rewarded by getting a little help. I tried to choose one that looked a little challenging because there is a negative term for the first one, and we have a fraction for the ratio. Okay, let's plug into our formula here then. The sum would be equal to the negative 8 over 1 minus 1/4. Now you remember with fractions, in order to subtract, we get a common denominator, so 4/4 minus 1/4 would be 3/4. So we have negative 8 over 3/4, which means negative 8 times 4/3. And I don't need to finish that for you. You can complete that last little step, but now you see where you're headed with that. And actually all of them on this page are of that type. So they look complicated, and it is kind of strange terminology perhaps at first. The formula isn't really that hard to use, and it only works if it is convergent. But I think all of them on the page, I think they all are convergent. And then in the score key, you'll see that they show all of these steps. So if you do get stuck, let your parent or supervisor show you the score key and see if you can figure out which step you missed or messed up. Okay? I hope you do well on this page.